Dear third prep, Assalamu alaikum wa rahmatullah wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Inshallah, in this lesson we are going to complete what we studied in the first video. Okay, we have Unit 1, Lesson 1, Cartesian Product Part 2. Okay, in this lesson, inshallah, we are going to complete what we studied before, and also we are going to study a new properties for the Cartesian product. Okay, now I have an example as we studied before, okay, in the Cartesian product, and this is example 3 completed what we studied before. Okay, here in this example, x equal 3, 4 and 8. Find the x product x and represent by arrow diagram and the Cartesian diagram. Okay, here x product x, because we have 3, 4 and 8, so I'm going to distribute x among x, so it will be 3, 3, 3, 4, 3, 8, also 4, 3, 4, 4, 4, 8, also 8, 3, 8, 4, 8, 8, and so on, like this. And because we have 3 elements, so the number of elements here equal 3 times 3 or 3 power of 2 equals 9. Okay, now to represent this one by the arrow diagram, I'm going to draw 2 rectangles. Okay, the first one is x, the second one is x, here x 3, 4 and 8. The second one also is x, also equal 3, 4 and 8. And I'm going to connect 3 with all elements and 4 with all elements and also 8 with all elements, like this. Okay, now I'm going to represent by the Cartesian diagram. I'm going to represent x horizontally and x vertically, like this. Okay, here x 8, 4 and 3 or 3, 4 and 8, also here 3, 4 and 8, and I'm going to draw the lines, okay, like this. Okay, and I'm going to represent the elements by dots as we took before. Here 3, 3, 3, 4, 3, 8, 4, 3, 3, 4, 4, 3, 8, 4, 3, 8, 4, 8, and 8, 8. Okay. Now let's remember the operation of sets as we took in the primary, because we are going to use this concept in this term, inshallah. Okay, here remember with me, if we have a set x included 1, 2 and 3 and set y included 3 and 4, by looking carefully to the two sets we find that 3 is a common, so I'm going, and we have another set u which called the universal set included from 1 to 6, as we see. To represent the 3 sets by Venn diagram, okay, so I'm going to do the following. X represented by oval like this, 1, 2 and 3, and y equals 3 and 4, so y connected with x at 3, like this. This is y. And finally u represented by rectangle like this. This is called Venn diagram. Okay, note here that 5 and 6 inside x and y. Okay, now remember with me the operations. We have 4 operations. The first operation called intersection. The intersection means the common elements of x and y. Okay, the common elements here is 3, and we are going to write 3 inside the set like this. Second, we have x union y. X union y means all elements at x or at y. Okay, all elements of x and y, 1, 2, 3 and 4, like this. Okay, now x minus y read as x difference y. X difference y means all elements at x, not at y, okay, or x only. Okay, here 3 included at x and y. The numbers which belong to x and not belong to y are 1 and 2, so it is 1 and 2. Okay, we have opposite to this operation, y minus x. Y minus x belong to y and doesn't belong to x, which is the number 4, like this. Okay, don't forget to represent them, the result always inside a set. Okay, now I have an example. Okay, example 4. Here x equal 1, y 2 and 3, 4, 2, 5 and 6, z 2, 5 and 6. Okay, represent x and y and z by Venn diagram, then find the follow. Okay, here by looking carefully, 1 and y are not common, or they haven't any common elements, but y and z have a common element, which is 2. So I'm going to draw two ovals connected to each other, okay, y and z, and x is separated for them like this. X included 1, and this is y and z. Okay, here inside I'm going to write 2, and here 3 is outside, okay, and 2, 5 and 6 inside z, like this. The first question with us is find x product y. Here x included 1, y included 2 and 3, so it will be 1, 2, 1, 3. Okay, the second question here, find x product z. Y product z. Here 2, 2, 2, 2, 5, 2, 6, 3, 2, 3, 5, 3, 6, as we see. Okay, number 3, x product z. X product z, 1, 2, 1, 5, 1, 6, like this. Here y2 or y product y. Okay, here 2, 2, 2, 3, 3, 2, 3, 3, like this. Okay, here x product y intersect z. Okay, x here is 1, y intersect z is 2, so I'm going to distribute 1 and the set 1 and the set 2, so it will be set 1 and 2 between brackets. Okay, now let's study the Cartesian product of an infinite sets. Okay, what are the infinite sets? The infinite sets looks like n natural numbers, z the set of integers, q the set of rational numbers, and r the set of real numbers. Okay, when we product or we distribute two infinite sets among each other, so I can't represent them by using Cartesian product because their elements are infinite. Okay, so I'm going to represent them by using the Cartesian diagram. Okay, so for example, if I need to represent the Cartesian diagram R product R, okay, I can't represent this by listing method, it's impossible, but I can represent them by using the Cartesian diagram as we studied before, x-axis and y-axis. Here x-axis represent the set R, okay, and y-axis also represent the set R. The two sets intersect at the middle at the origin point, which called 0. Okay, this location represent R product R. This is the first R and this is the second R. Okay, for example, if we have a point like this, point 3 and 1. 3 and 1 represented here in this position. Starting from 0, okay, go to the right 3 steps and go up 1 step, it appears here in this position. Okay, this one is called this quarter. Here we have 4 quarters. This quarter is called the first quadrant. Okay, so by looking carefully to 3 and 1, 3 is a positive number, 1 is a positive number. Though the first quadrant, the two numbers are positive, so like this here, 3 and 1 belongs to the first quadrant. Okay, another example. If we have another point, -5 and 1. -5 and 1, here -5 and go up to 1 appears in this position like this. This quarter called second quadrant. Okay, the second quadrant, the first element is negative, the second element is positive, so it is negative, positive, like this. So any point, it's called the first projection negative and the second is positive, belongs to the second quadrant. Okay, Now another example, -5, -2 here in this position. This is the third quadrant. Both of them are negative. It's very easy. Okay, finally, if we have a point like this, 4 and -1 appears here in this position. Okay, 4 and -1. 4 and -1 appears in the fourth quadrant. The first projection is positive and the second is negative. You don't need to memorize these rules. You just need to memorize the coordinate axis, x-axis, y-axis. Here in the first quadrant, x positive, y positive. So both of them are positive. The second, x negative, y positive, negative positive. Here, both of them are negative. Here, the first positive, the second is negative. Okay, and I have another example. Example 4. Okay, example 5. Choose the correct answer. Number 1. The point what lie in the second quadrant. Okay, remember with me, the second quadrant, the first is negative, the second is positive. So this is B. Okay, -2 and 3. Here number 2. The point x and 7 lie on y-axis. Okay, any point belong to y-axis, its x coordinate is 0. Okay, so x here equal 0. Okay, and the opposite, any point belongs to x-axis, its y coordinate is 0. Okay, another example, number 3. The point 5 and b minus 7 belong to x-axis. Okay, this point belongs to x-axis. So here b minus 7 equals 0. So b minus 7 equals 0. So b equals 7. Okay, because 7 minus 7 equals 0. Okay, finally number 4. The point x minus 2 and x minus 4 lie on the fourth quadrant. So x equal what? Okay, the fourth quadrant, remember with me, the fourth quadrant, the first is positive and the second is negative. Okay, by using 0, 0 minus 2 and 0 minus 4 gives negative numbers. So it is not 0. By using 2, 2 minus 2 is 0. Okay, I don't need 0. I need the first positive and the second negative. So it is not 2. By looking to 3, 3 minus 2 equal 1 and 3 minus 4 equal -1. So this is the answer, because 1 and the -1 belong to the fourth quadrant. Okay, and finally, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.